just to explain then Pythagoras' theorem and as far as electronics engineering goes and where we're going to be using it in the AC subject. If we think about the 3, 4, 5 triangle and the fact that I've got one side with 3 units on it, one side with 4, and the hypotenuse over here, the longest edge, with 5. So we call this a 3, 4, 5 triangle. And the hypotenuse length is given by a squared plus b squared equals c squared. And we can rearrange that equation to make that into side c. The hypotenuse is equal to the square root of a squared plus b squared. And then if we do the maths on that, we've got the square root of 4 squared plus 3 squared equals 5, satisfying the fact that we've got our 3, 4, 5 triangle. However, I've drawn in red here against our 3, 4, 5 triangle. I've lifted this side, which is 3 units, up to the top. It is actually now a square, so these two sides are the same length. And this side 4 is going to be the same dimension over here. So 3 and 4. But if I think about mirroring this triangle and lifting it up to make the 3 at the top, keeping this side 4 over here, and then plotting my hypotenuse down through here. So now the hypotenuse has moved to here, and it's still going to be length 5. This, well, before I talk about the angle, let's have a think about Cartesian coordinates and explaining to somebody how they're going to get to a location. If you want to go to this location here, you could say to somebody that you're explaining directions to, you're going to go north, walk north 4 kilometres, and then turn right and walk east 3 kilometres, and you'll get to your location. But because the shortest distance between 2 points is a straight line, wouldn't it be nice if you could just say to somebody, hey, here's a compass. All you've got to do is follow this compass bearing and walk in that direction for 5 kilometres and you'll get to where you want to go to. So if we know this angle in here, we already know that we've got a length of 5 to get to point X. All we have to do then is calculate this angle. And if we think about a bit of trigonometry, we can do that using the tangent of that. Tangent of theta is going to be equal to the opposite over the adjacent side. And in this case, the opposite is going to be 4, and the adjacent is going to be 3. Hence, tan theta equals 4 on 3. Hence, we can find theta will be equal to inverse tan 4 on 3. And if we run the maths on that, we'll find out that theta is equal to 53.1 degrees. So, wouldn't it be nice to tell somebody, using polar coordinates, use your compass and walk from the horizontal 53.1 degrees above the horizontal, above the eastern plane, in a direction for 5 kilometres, and you'll be at point X. And this is really polar versus rectangular. So we looked at rectangular first of all with simple Pythagoras, and then we've gone on to look at polar coordinates and talk about an angle with a length of a resultant or a hypotenuse. And I've made a second video about this already, showing how to use an FX100 Casio calculator to do rectangular to polar. And I do plan to go on and do that with some more calculators as well.